Production tables can really help you solve some very difficult problems. Here's a problem. 3 identical machines will make 4,000 widgets in 5 hours. How long will it take 5 machines to make 2,000 widgets? I have no idea. But a production table will tell me. We use a production table starting with the given details and change one factor at a time to obtain the answer. So here is a production table: machines, widgets, and time in hours. Great. Let's put in the given information. 3 machines, 4,000 widgets takes 5 hours. And I'm going to manipulate these two to get what we want. And we want, we want 5 machines and 2,000 widgets. It's important to remember, if we increase the machines, then the time goes down. If we make it 6 machines, we've doubled the machines, we'll half the time. But with widgets, more machines reduces the time. With widgets, if we make more widgets, it increases the time. 8,000 widgets will take 10 hours. So these two columns act differently, and I mark them with these arrows so I can remember, because I tend to forget things. So with the arrows intact, let's get started. We want to make 2,000 widgets, so I will reduce this to 2,000. So I'm only doing half the work, and it's only going to take half the time, still with 3 machines. I want to use 5 machines, but I'm currently using 3. So I'll find out what 1 machine does, then multiply by 5. So I'll reduce the machines to a third. I have to increase the time by 3. We're still making 2,000 widgets. Now I'll increase the machines by 5-fold to 5. I'll reduce the time 5-fold to 1.5 hours, still making 2,000 widgets. 5 machines make 2,000 widgets in 1.5 hours. 5 machines make 2,000 widgets in 1.5 hours. I don't know how I'd answer that question without this table. Most of the questions you're going to face are quite easy and you can work in hours. But if it becomes difficult, for example, if the fractions involved, it might be an idea to go to minutes. So you work out the number of minutes and you come down in the same way. 90 minutes, which is 1.5 hours. Thank goodness for that. Right, let's have a look at another example. 2 workers can dig a 12-metre trench in 8 hours. How long will it take 4 workers to dig an 18-metre trench? Right, here's my table. Workers' length, time. Put in the data. 2 workers, a 12-metre trench takes 8 hours. Right, okay, I'm going to manipulate, or first of all, I'm going to mark these. Increasing workers reduces the time. The length, obviously, of the trench will increase the time. I'm going straight to 4 workers now. So I am doubling the number of workers, which will half the time divided by 2. It'll still be 12 meters long. Now I want to get from 12 meters up to 18 meters. So I'm going to do that via 6 meters. I'm going to halve this and then double it. So halving the length of the trench will half the time. It only takes 2 hours if you've got 4 workers. And now I'm going to make this 18 meters. So I'm going to multiply it by 3. So I am going to multiply the work by 3. There's still 4 workers. So 4 workers will dig an 18-metre trench, and they'll take 6 hours about it. Now, you know me, I do like a check. The problem with this check is it's difficult. You'll forget it. You might do it and confuse yourselves. So only if you're really confident. Take the one that's going up, length, and put it over workers times time. And for each row, this is going to equal a constant. In this case, it equals 0.75. It won't be the same with different questions. So I can do this. 12 divided by 2 times 8 is 0.75. And I know that 18 divided by 4 times 6 is 0.75. If it isn't, you've gone wrong. But as I say, that's a difficult check. And if you don't fancy it, don't try it. I did, and I'm right. Thank you very much. Here's another example. This is a bit more complicated, probably harder than you will face in any exam. 5 workers pack 400 boxes in 4 hours. How long will it take 4 workers to pack 600 boxes? Well, we know what to do. Workers, boxes, and time. and we put in the original data, 5 workers, 400 boxes, 4 hours, and we mark that more workers bring the time down, more boxes pushes the time up. Now, this is difficult because 5 to 4 isn't nice and 4 to 6 isn't nice, but let's get started. I'm going to work out what 1 worker will do. So I'm going to divide this by 5, and I'm going to multiply the time by 5 because it'll take that 1 worker 5 times as long. Boxes remains the same. Now I'm going to increase the workers to 4, multiply by 4, which will divide the time by 4 and make it 5 hours. Boxes remain the same. So that's the workers sorted. Boxes need to go from 400 to 600. Easy way to do that. Divide 400 by 2. So that's dividing the boxes by 2. We'll divide the work by 2, obviously. So that's 2.5, still with 4 workers. And now my boxes, I'm going to treble from 200 to 600, which means the time will treble times 3, 7.5 hours, still with 4 workers. So 4 workers making 600 boxes, packing 600 boxes will take 7.5 hours. 4 workers will pack 600 boxes in 7.5 hours. Let's have a look at that check. Boxes on top because it's punching up, workers and time below. Boxes over workers times time. 400 over 5 times 4, 20 equals 20. 600 divided by 4 times 7.5, that's 30. 600 over 30 is 20. Very happy with that. Right, as I say, that check's tricky. If you don't like it, don't do it. Just make sure you get the rest right. Here we go. Here's your chance. I'm going to give you 10 seconds to pause the video, and you can have a go at solving what is a difficult problem, but solve it in a clever way using a production table. How did it go? Hope it went well. Here's your table. Ovens, cakes and time. Right, the original data is 6 ovens, 120 cakes in 3 hours. Right, let's have a little think how we're going to do this. Well, more ovens brings the time down, more cakes pushes the time up. And we're going to look at ovens. We're going to reduce the ovens down to 1 so we can go back up to 4. Reducing the ovens to 1, we'll keep the cake, dividing by 6, we'll increase the time by 6. It's now going to take 18 hours for that 1 oven to bake 120 cakes. But I'm going to increase that by 4 now, 4-fold, which is going to divide this by 4, 4.5 hours. So 4 ovens will take 4.5 hours to make 120 cakes. And I'm going to get the 120 cakes down to 40 by dividing by 3. So that'll take the time down by a factor of 3. We divide by 3, 1.5, and we've still got 4 ovens. So 4 ovens to bake 40 cakes will take 1.5 hours. There's a summary. The check, if you want to do it, cakes on top because the arrow points up, ovens and time underneath, and that's a constant. In this case, it is, oh, it's a nasty one, isn't it? It's 6.666. So hopefully you've got a calculator. If this isn't a calculator problem, this check's going to be tricky and I wouldn't bother doing it. Anyway, we got it right. So what do? Think, recognise, is this a production table problem? Are the machines and workers, are the products, and is there time? If it is, draw the table and then change the values to get the desired result. And if you really feel confident, go for the check. The one that's going up with time, the product, as it were, is on the top. The workers, ovens, whatever, are on the bottom times time. But don't do that if you don't feel confident. And that equals a constant. We've taken a nasty little hard question. Doesn't get many marks though, so I think everyone must use this technique. And we've made it tricky but doable. So, if you want to see more videos, or even if you don't, subscribe. And if you're taking an exam soon, best of luck. Right, what am I doing? I'm stopping.